Okay, Trig. Section 2.5, I'm going to get, I don't know, just like about 3 examples done. We're going to save the calculator one for when I'm with you tomorrow in class, but I'm going to do probably example 1, example 2, example 4, and then we'll maybe save 3, 5, and example 6. We might do 5. I don't know. We'll see. We'll see how long this takes, but inequalities means not equal. And if it's not an equal sign, I always say, well, what is it? What is it if it's not an equal sign? It's going to be a less than, a greater than, a less than or equal to, or a greater than or equal to symbol. So those are non-equal signs. They are ways of showing that two things are not equal. One is either less than the other, one is greater than the other, etc. Okay, so a lot of times you'll have stuff like, let's say x is greater than 3, or x is less than or equal to 5, okay? And they will sometimes represent this as interval notation. Okay, so what this will look like is if x is greater than 3, I think about that on a number line. If x is greater than 3, it's an open circle and it's going this direction. So in interval notation, how we represent that is we say that x is going from 3 to infinity. Okay, he goes from 3 to infinity. And when on the side that has infinity, you will always have a parenthesis, but the other side will be a parenthesis if it's an open circle, so it's not equal to, and it's a bracket like what's here. It'll be a little bracket if it is equal to. So I'll show you kind of how that is in the second one. So this is interval notation for x is greater than 3. Okay, x is less than or equal to 5 on a number line, if you think about it, is a closed circle going this direction. So in other words, he's going from negative infinity, which is all the way down over here. Negative infinity is as far left as you can go. He will always have he'll always have a parenthesis around him, comma 5, and he will have a bracket. Okay, so the way that I can remember that a bracket goes around an equal to sign is because it has these horizontal lines on the bracket, and an equal to symbol has a horizontal line as well. So if it's equal to, you'll have a bracket. If it's not equal to, you'll have a parenthesis. If it's an infinity, you will always have a parenthesis. Okay, now let's say you have the scenario where you have like negative 3 is less than x, which is less than or equal to 5. Okay, let's say you have that scenario. In that case, on the number line, it's like this, negative 3, and it's 5. You would have an open circle on negative 3 because it's not equal to, closed circle on 5, and you're touching in between them. So in that case, your interval notation will look like negative 3 comma 5, because that's the interval it's going from. It's no longer got an infinity in it because it's bounded on two sides by two different numbers. These ones only had a bound on one side, okay? And they went to either infinity or negative infinity. But these guys are bounded on both sides. The negative 3 will have a parenthesis, and the 5 will have a bracket because he is equal to, but the negative 3 is not equal to. So that's what the interval notation will look like. Okay, and you can kind of see that here, like these two have brackets, so, and they have both equal to symbols. These two have parentheses, so they have not equal to, they're just less than, less than. This one has a bracket on the one side but a parenthesis on the other, so bracket, parenthesis, and parenthesis bracket, that's less than or equal to. Okay, so that's kind of how that works. If it has an equal to, it's a bracket. If it doesn't have an equal to, it's a parenthesis. If it has infinity, it's always going to be a parenthesis on that side of it. Okay, all right, I'm going to skip the basic principles for solving inequalities because it's, we don't need to go over that. I'm going to do example 2 before I do example 1. So I'll teach you how to do these 2 different ways. These are called compound inequalities, and they're compound because we have basically 3 pieces and they're separated by 2 sets of symbols. Okay, so this would be kind of like having 2 equal signs. You have like 3 equations separated by 2 equal signs, but they're not equals, they're inequalities. Okay, so some people like to do this. If I look at just this left side, I will have 4 is less than 3 minus 5x. I have that to deal with. And then I have this right side. I'll do it in a different color. I'll have this right side piece. which is 3 minus 5x, is less than 18. So really that middle part appears in both of the equations. Okay, the middle part appears here and the middle part appears there. Okay, and then we just solve them. So I want to get the x by itself. I'm going to subtract the 3 over. So 4 minus 3 is 1. 1 is less than, this will be negative 5x. And remember that when you divide by a negative, you have to flip the sign. So negative 1 over 5 is less than, no, excuse me, I just said flip the sign and then I didn't do it. Greater than x, right? You have to flip this sign right here when you divide by a negative. If that bothers you to have the x on that side, we can flip him around and say x is less than negative 1/5, like that. Some people like to write it like that way, and that is totally fine. Let's go ahead and solve the other side. So 3 minus 5x is less than 18. Okay, subtract the 3, subtract the 3. Negative 5x is less than 15. And then we divide by negative 5. Again, we're dividing by a negative, so we have to flip the sign. X is going to be greater than negative 3, and that's what he will look like. Okay, so there's that. Now, this, okay, I'm going to go over and do an example 1, and then I'll bounce back to example 2 and kind of show you why this doesn't work. So in example 1, if I don't want to separate them out like I did example 2 and do like the 2 different cases, I could leave these together. And what I do is I'm looking for that x in the middle, and when I want to try to get that, well, I don't know that I can even do that either. Never mind, just disregard what I said. Because there's an x over here, this makes it a problem, so I can't do that. I do have to separate this out into 2 pieces. So that piece and this piece, because that x on the right side, that's going to complicate things. We can't do that. So just ignore what I was trying to say just now. 2 is less than or equal to 3x plus 5. And then I have 3x plus 5 is less than 2x plus 11. Okay, so over here, let's subtract the 5. Minus 5 minus 5. This guy will be negative 3, less than or equal to 3x. We're going to divide by 3, divide by 3. So x on this side, negative 1 on this side. I do not have to flip my symbol because even though I have a negative over here, I didn't divide by a negative. Okay, so I can have it looking like that. If you want to flip that around, you can say x is greater than or equal to negative 1 if you like to have it, where the x is on the left side. All right, then let's go ahead and solve. So I'm going to get the 2x with the 3x here, and I'm going to go ahead and subtract the 5 at the same time, if I can do that. 3x minus 2x is x, less than 6. Okay, and he is already solved 4. Okay, so I'm going to think about what the graph of these guys look like just real quick. On a number line, so if I focus on this guy right here, negative 1 is here. He's an open, he's a closed circle because he's equal to, and x is greater than that, so it's going that direction. Okay, this guy right here says x is less than 6. So I go to 6. It's not equal to, so I put an open circle. And he is less than, so he's going this direction. Okay, because those two things touch each other, I could write this as a compound inequality. I could put those guys together, and what it would look like is negative 1 is less than or equal to x, which is less than 6. And I could write it as one piece, just like that. Okay, notice that when I write it as one piece, both of these symbols go the same direction. They're both less thans. Okay, so it's kind of like taking this original guy and this guy and slamming them together and just having one x in the middle. Okay, so I could write him like that. Now, example 2, I'm going to show you why that doesn't work for example 2. Remember when we divided by the 5 and we had to flip the sign? Okay, what's going to happen here is that I have negative 3 is on this side, right? Negative 3 is to the left of negative 1/5. Okay, so if I focus on this guy right here, x is greater than negative 3. Is that right? Maybe this will work. This will work. X is greater than negative 3. Boy, I'm just full of it today. Sorry. And it's not even that late. It's only 9:27. X is greater than negative 3. Open circle. X is less than negative 1/5. So open circle again, and we go this direction. Okay, so I could still write that as a compound inequality. I would start with negative 3 on the left, less than x, which is less than negative 1/5. And that's how I could write it like that. okay? Every once in a while, you'll end up with inequalities where you have like, I don't know, I'll do the same numbers again, -3 and -1/5. If they would go the other direction, you would not want to write them like this, and you would want to leave them separate, okay? So just keep that in mind. If that happens, don't try to write them as a compound inequality where you have x in the middle of everything, okay? Just kind of think about what it looks like. All right, and you don't have to graph each one of these, just kind of think, can a number be greater than -3 and less than -1/5 at the same time? If they can, you can write them together. So you don't necessarily have to graph them, okay? I'm going to leave that calculator part for tomorrow when we come back together. Let's do example 4, so solving a quadratic inequality, okay? So I've got this guy going on right here, and we're just going to worry about kind of like treating this as though it says equals 0, and we're going to try to solve for x. So whatever way you want to use to solve for x, you can use the quadratic formula, you can factor, you can do anything like that. I think I don't know if we can use the quadratic formula or not. Or not quadratic formula, if we can factor. If we factor, we have to do a complex trinomial. 2 and -4 multiplied together is -8. Don't write this down because I don't think it's going to work. Then we have to do -8. Two numbers that multiply together give me -8. When I add them, give me 3. And I don't think that works. So I think we almost have to do the quadratic formula in this case. Okay, so let's go ahead and do that. Let's do -b, which would be -3. Plus and minus square root b squared would be 3 squared, which is 9. If I'm ever going too fast, please pause this video or rewind. You know, I feel like I go faster recording these than I do actually in class, but if I'm going too fast, please pause it, or you know, whatever you need to do. Okay, b squared minus 4 times a is 2, and c is -4. Make sure you include that negative in there. All over 2 times a, which is 2. Okay, so let's simplify this a little bit. -3 plus minus the square root of -4 times 2 times -4. This piece right here will be a positive. 4 times 2 is 8, times 4 is 32. So 9 plus 32 is 41. I'm going to do that inside of there, all over 4. Okay, and I don't have my calculator. Of course I don't. Hold on just a second. We're going to go ahead and convert these to decimals. There we go. I'll use this guy. We're going to convert the square root of 41 to a decimal. So if you've got your calculator handy, you can probably get this faster than I can. Here we go. 41 square root. It is 6.4. We'll go one decimal place. It doesn't have to be too perfect. 6.4 is what he comes out to be after you take him out of the square root. So I have -3 plus 6.4 divided by 4, and I have -3 minus 6.4 divided by 4. Okay, so let's do that real quick. I'm using my phone as a calculator, which I do not recommend at all. So -9, that's not what I want to do. 3.4. 3.4 divided by 4. Okay, if I take -3 and I add 6.4 to it, that would be 3.4 divided by 4 is 0.85. Okay, and -3.4 or 3 minus 6.4 is a -9.4. And I'm going to divide that by 4, and that is -2.35. Okay, now what I'm going to do is, because this is a quadratic and we have weird things going on and we have two answers, I always put this on a number line. Okay, always. When it's quadratic, when it's more than just a linear, like these two were, it was just x to the first power. When it's quadratic, I always put it on a number line. -2.35 goes on the left side, and 0.85 goes on the right side. Okay, and so we've got to figure out, you know, which way these arrows are facing. I know from this simple that they're both going to be closed circles, but I've kind of lost the direction that my inequality is facing. I don't know, you know, how those are going. I do know that they're closed circles. So what we're going to do is we're going to pick some test points. I'm going to test a number here, test a number here, test a number here, and we're going to see which region should be like filled in or should be shaded. So I'm going to choose like -3 over here. Okay, it's just a number on that side of -2. You could have chosen -4 or -5, doesn't matter. The easiest number between -2.35 and 0.85 is just 0 itself, right? And on the right side of 0.85, a good number to use is 1. Okay, so we'll just use those 3 numbers and we'll test them. Okay, so I want to do 2 times -3 squared plus 3 times -3 minus 4, and I want to see if that's, less than or equal to 0. So -3 squared is 9. 9 times 2 is 18. Okay, 3 times -3 is -9, and then minus 4. So let's see, 18 minus 9 is 9, and 9 minus 4 is 5, and 5 is less than or equal to 0. No, 5 is not less than or equal to 0, so it's not going to be this range that I'm going to shade. Okay, now I'm going to do the same thing again, but I'm going to plug in 0. Okay, so 2 times 0 squared plus 3 times 0 minus 4 is less than or equal to 0. 2 times 0 squared is going to go away because it's going to be 0. 3 times 0 is going to go away, so I just have -4 is less than or equal to 0, which is true. So it's going to connect these two pieces. And I'm guessing if that happens, 1 is probably not going to work, but let's plug it in just to check to make sure. 2 times 1 squared plus 3 times 1 minus 4 less than or equal to 0. So 1 squared is 1, 2 times 1 is 2, plus 3 times 1 is 3, minus 4. 2 plus 3, again, if I'm going too fast, slow down or pause. 2 plus 3 is 5. 5 minus 4 is 1. Is 1 less than or equal to 0? No, it is not. So the region that I want is this guy. And I'm going to write that as a compound. So I have -2.35 is going to be less than or equal to, because that's what my symbol said, equal to x, which is less than or equal to 0.85. Okay? I always, when it's a quadratic, put it on a number line just to check to make sure that I'm shading the right region or whatever, because it could very well go this opposite direction and then I wouldn't know for sure. Okay, so I always check to make sure. If I want to write this in interval notation, just kind of pulling this back into what we talked about at the beginning, -2.35 would be my first number, comma, 0.85 is my second number, and both of them would be brackets. Okay, don't get wrapped up in trying to think about this as an ordered pair, like when you're plotting points or whatever, like -2 comma whatever. It doesn't have anything to do with that. This is just meaning a region. Okay, so when you're in interval notation, it looks like you're saying x comma y, but it's not. And this one in fact has brackets, so it really doesn't look like x comma y. But even when you're using parentheses, like this guy did part of the side here, that doesn't mean -3 comma 5. That's what you're plotting. That's the region from -3 to 5, all of those values in there. Okay, so you can write your answer this way or this way. If they ask specifically for interval notation, you're going to want to do this bottom one here, but both of those mean the same thing. Okay, all right, I'm going to go ahead and save example 3, example 5, and example 6 for tomorrow when we come back together. Okay, there you go.